Hey everybody, I got a lot of requests for this review, so I'm just going to jump right into it with some of the non-calculator stuff first. So starting with number 2, this is just a weird version of the average value formula. So normally you set up the area of a rectangle and you set it equal to the area of the curve. Well, here we don't really know what the width of the rectangle is, or the interval over which we're integrating. So that's what makes it a little bit weirder than every other time we've seen this question. But it is the same. We're going to set up the area of a rectangle being going from 0 to k, so it's just k units wide. And it is still f of c units high, which is what we're solving for. F of c is going to be the average value, and we'll set that equal to the integral from 0 to k over our function x cubed. So let's just solve for f of c like we normally do. Forget for a second that k is kind of giving you a headache and confusing you. So let's see, we're going to just integrate x cubed. From 0 to k. And I know that looks weird, but we're just going to plug k in like it is any other number. And then it'll be minus 0. So just 1/4 k to the 4th. Now that is k times your average value. We can solve for our average value. F of c equals 1/4 k cubed. And I already know that our average value is supposed to be 9. So normally we would have solved for our average value right there, but it's in terms of k. We know the average value is supposed to be 9, so set it equal to 9. And then just solve for k, and you're done. Multiply both sides by 4. Take the cube root. And there you go, you got your answer. Okay, now here we are with number 4. All you're given in the prompt is the acceleration function, 24t squared. So it's up to you to integrate. You could do it once or twice to get the velocity function and or the position function. If you integrate this, your velocity function should be 8t cubed plus v naught, which is 0, because it does say in the question that you start from rest. So technically it's plus 0, but you obviously just get rid of that. If you integrate again, you'll get the position function, which is 2t to the 4th. And then again, you have to tack on the initial position, but since we're really only caring about how much distance is covered and not necessarily where exactly we are, we can just call our position at 0, 0, or 0 mile marker, because it doesn't really matter. Anyway, you can just now find out where you are after 2 seconds, which is going to be 32. So at t equals 0, we were at 0, and at t equals 2, we got to 32, so we covered 32. 32 whatevers. All right, guys, here we are with number 17. You have a bounded region bounded by y equals 4x, y equals 8, and the y-axis. So that encloses this red triangle here. We're spinning around y equals 8, so we get to use the disk method because each rectangle is going to be spinning around itself. So you just need one radius, and it's going to be top minus bottom. That's going to be 8 minus 4x. And square that radius. So there's your formula, pi r squared. And we're integrating from 0 over to wherever these things intersect, which is at 2. Obviously, I just set 4x equal to 8 to get the intersection points. Anyway, the easiest way to integrate this, or at least one way, is probably to just FOIL this whole thing out. And then integrate. 142. Minus 0, if I plug 0 in, that's not going to do anything. So there we go, they cancel, that's nice. 128 pi over 3. There you go, that's your answer. Alright guys, for number 19, the hardest part about this problem is definitely all the tedious algebra after you get the calculus set up. You have your region bounded between x squared minus 1 and 1 minus x squared, and apparently you're spinning around this horizontal line y equals 3. That's way above your shape. So that tells me we're definitely using the washer method. We're going to need 2 radii. If this is one sample rectangle, just be aware of what your 2 radii are going to be. You're spinning around this thing, and this side of the rectangle is further away, so that'll be the measurement for our longer radius. If we're spinning around this and this side of the rectangle is closer, then that's going to be the smaller radius. But let's go ahead and set the thing up. We've got pi. Looks like we're going from -1 over to 1. And our big radius is going to be 3 minus that function. And all of that gets squared. And then minus the smaller radius, 3 minus that function. And square that whole thing. So you can see this thing's getting ugly. So we've got pi, big R squared minus pi, little r squared. Everything's set up well. We just have a whole lot of algebra to do at this point. This is another one of those non-calculator questions. So as tempting as it would be to just throw that whole thing in your calculator and get an answer, this is something you gotta make sure you can do by hand. And I'm gonna try to give you some hints, but I think the only thing we really can do is cut the shape in half. That's one trick I'm going to show you. This is symmetrical around the y-axis. So instead of going from -1 to 1, I'm just going to double my answer and go from 0 to 1. I love when 0 is one of my bounds, because it usually just, when we plug 0 in, it kind of just does nothing. And then I'm just going to clean all this up until I get an answer. So let's get at it. Let's see. Alright, so it looks like those guys cancel. And I got 16 minus 4. And I think that should have been squared. There we go. Alright, so just do all that algebra first, just to clean up your integrand, and then we'll go ahead and finally integrate. I hope you guys can see this okay. I know I'm writing kind of small. And this is why we love having 0 in here. I plug 0 in and I get nothing, so that's done. So we just have a 16 pi. And there you go. Okay, number 20, we have a known cross section. We're told the base of our little building is going to be bounded by x squared, x equals 4, and the x-axis. And all the cross sections of our building are going to be perpendicular to the x-axis. That tells us we get to use dx. Here's sort of a 3D model of what we're making here. Each of the cross sections are going to be equilateral triangles. We've done this problem before. We know the formula. It's going to be root 3 over 4 times the integral from 0 to 4 of the side squared. And any side of the triangle is going to be measured by just that distance, which happens to be just the length of this green line here. So that's going to be top minus bottom, x squared minus 0, so just x squared squared. Root 3/4 s squared is the formula for an equilateral, the area of an equilateral triangle. So let's see, we've got root 3/4. This will be 1/5 x to the 5th from 0 to 4, and just more ugly algebra. No big deal. Root 3 over 4 times 1/5 times 4 to the 5th. I'm writing it that way just to save us a little bit of brain power. That 4 can cancel with one of these. So we have root 3 over 5 times 4 to the 4th, which we know is 256. So 256 root 3 over 5. And there you go.
Hey guys, I'm going to pop over to my computer for some of the calculator-based questions, just in case I need to pull up the calculator for any reason. So let's start with number 5. We have a velocity function, and we want to know the total distance traveled between 0 and 2 minutes. So if this is a calculator question, the easiest thing for you to do is definitely to just graph it, or you could do this over in your scratch pad, but I need to integrate this thing, well, sort of this thing, from 0 to 2. But before I fix this, you just want to realize that this is the velocity function. So from here to here, from 0 to almost 1 minute, it looks like we have a positive velocity. So we're moving forward. But then you notice from that point up to 2 minutes, we're moving backwards. And the trick with this question is that we were asked for total distance traveled and not just the displacement. So if I were to integrate this thing from 0 to 2, we get negative 0.704. So let me just see, yeah, that's sort of one of the wrong answers. That's going to be your total displacement, meaning you moved 0.704 whatever's backwards from where you started, but you had moved forward first. So we actually want to either integrate from here to here, and then from here to 2, and add up those two distances, or I can cheat and just let's just do this. Take the absolute value of that whole thing. So I just forced the whole graph to be positive. So now I'm going to run the same. Actually, you know what? It updated. Oops. The integral from 0 to 2 is now 1.54, which is the correct answer. Okay, so there's number 5. Number 6. We have a rate function. We've got oil leaking from a tanker at this crazy rate in gallons per hour, and we want to know how many actual gallons leaked out of the tank between 0 and 10. So if that's your rate function, which gives you gallons per hour, the integral of that, the integral of gallons per hour, is going to be actual just gallons. So you want to integrate that function between 0 and 10, and I'm assuming that'll give us 8647. So let's just see. Hold on. There we go. All right, so what was that function? 2000 e to the negative 0.2 t. And I want to integrate that thing. 0, 10. There you go. 8.65 e plus 3. That just means times 10 to the third. So 8,650. There you go. Good enough for government work right there. 8647. All right, what was the next one? Number 12. Okay, you just want to find the area enclosed by these functions. So I'm just going to pop right back to here and cheat again. Let's see what they look like. X cubed. And x plus 5. Okay, this is weird. I'm assuming this little tiny bubble is the only actual enclosed region. It didn't mention either of the axes. So, I'm going with just that little tiny bubble right there. Just get rid of this stuff. Now, on the calculator, you can actually just find bounded area. But I should have been more accurate. Let's try that again. The real way to do this is to find out where these guys intersect and set up a whole new integral. But just for the sake of time, I'm going to cheat a little bit. Let's find bounded area. There we go. 0.583. Let's see. Yeah, that's not right. Oh, hold on. This whole bubble is also being bounded. Duh. How about 11.8? There we go. That looks better. Okay, moving on to number 4. Oh, I got a lot of requests for 14. Okay, you've got the base of a solid in the first quadrant, bounded by that line, and all the cross sections perpendicular to the x-axis are semicircles. Okay, perpendicular to the x-axis, that means we're going to get to use dx, and if every cross section is a semicircle, then our formula is 1/2 pi r squared. You just have to figure out what r is. There's no great way to, I don't really have a, I'd rather do this one by hand, but let's just, let's go to the scratch pad. Alright, so if the formula is 1/2 pi r squared, pi, the integral from, looks like from 0 to 8. It's going to be in terms of x because we're using dx. Now, this distance from the top of that line down to the x-axis, that's going to be the whole bottom half of your semicircle. So I actually only want half of that distance, because that would be r. I don't want to do this whole entire distance. That would be my diameter. I just want half of that. So my radius is going to be 0.5 times whatever this distance is, which goes from the top line down to 0, so it really just is the top line. So I just have to manipulate this and solve for y. So that'll be 8 minus x over 2. All right, now that whole thing is the radius, is the radius. So we have, just recapping this before I hit enter, here's the entire radius. 8 minus x over 2, we take half of that, that's our radius. Square it, times pi is the entire circle, multiplied by a half. There we go, we've got the half of the circle. Integrate from 0 to 8, I think that should do it. 16.7. Bam, there you go, 16.7. So I hope that helped. Number 16. Okay, y equals secant, x and y axes, and x equals pi over 3. What are we doing? Rotating this around the x-axis? Okay. So just get this straight again. It is this line, the x-axis, the y-axis, and x equals pi over 3. So it's this. It's just like this little region right here in the first quadrant. And what are we doing? Going around the x-axis. All right, that's easy enough. So we're going to use dx, just the disk method, because there's no washers, there's no holes in the middle. So let's just go right out to here. Pi r squared. Integral goes from 0 to pi over 3, and the radius is just secant x. So there we go, pi r squared from 0 to pi over 3, 5.4. And now we're going to figure out which one of these is 5.4, and I'm pretty sure it's, what's that answer? Pi times root 3. Hey, look at that, we got a winner. You can't see it, there you go. Okay, what are we on? Number 18. Hey guys, so I am doing number 18 again real quick. My last video could finish number 18. So we have an ugly sine function and y equals x squared, and then we're going to spin that thing around x equals 2. Now the problem with this is that x equals 2 is vertical, so using a dx kind of rectangle isn't going to make a disk or a washer, so everything's going to have to be in terms of y, which isn't a real big deal with that thing. We could turn that around and call it x equals root y, but this thing's going to be nasty. if we say y equals the sine of all that junk, then the only way to solve for x is to take the arc sine, or the inverse sine of both sides. So take the inverse sine of both sides. Let me get that stupid thing out of your way. And then you just multiply by 2, divide by pi, and here we have x equals 2 over pi, the inverse sine of y. And the other function we're using is x equals root y instead of y equals x squared. So let's pop back to here. If we're spinning around x equals 2, then while this is my dy kind of rectangle, the big radius is going to be the distance between 2 over here and way over here. This side of the rectangle would be further away, so that's my big radius. And again, when you do things in terms of y, you got to do right minus left. So 2 minus that function. And that's the function we're going to call 2 over pi arc sine of y. Square that giant radius. Then we're going to subtract the other smaller radius squared. So that's going to be 2 minus this side of the rectangle. And that's hitting the x equals root y function. So 2 minus root y, and then we'll square that radius. I'm just going to pop down to here because you can't do it better than this. Here we go. Pi big R squared minus pi times little r squared. And the integral is definitely from 0 up to 1. I know it looks like we're also going from 0 over to 1, but technically we're going up in terms of y. Everything's got to be in terms of y. So 0 up to 1, those are your bounds. So there's your integral. You just throw that right in your calculator. Please don't try to do that by hand. You can do it in your scratch pad using y and dy, or whatever variables you want. It doesn't really matter what variable you put in there. Just throw that in your scratch pad and you should get 2.8. Okay? Hope that helps. Hope everybody's staying safe and sane at home. If you have any questions, any follow-up questions to any of these videos, just shoot them my way and I'll reach out to you personally and I'll try to clear up any confusion you guys have. So other than going through all these videos today, I just need you to, I don't need you to do anything today. I'll send out another assignment either online or on the workbook tomorrow morning. Okay? Talk to you guys later.